Alright, in this section here we're going to be graphing some quadratic functions. So in the past we have been focusing mainly on just linear functions, but in this section it's quadratic. So first thing we need to do is, what is a quadratic function? Well, a quadratic function looks like this. Now I'm going to write it like it's an equation. You know, we could write f of x here if we wanted to, but I'm just going to write it with y is equal to ax squared plus bx plus c. Okay, a, b, and c are all elements of R. Alright, so these can all be real numbers, except we'd have to say that a cannot be equal to 0 if we want it to be a quadratic function. Now, of course, we're focusing here on graphing quadratic functions, and we're going to look at their graph, and we're going to identify what's called the vertex on the graph. So let me just kind of sketch out, and of course we're going to actually use a graphing utility because my pictures aren't pretty most of the time. This one here, we'll say y is equal to x squared. Alright, so I'm going to try to graph this out. What does this graph look like? And it looks something like this. Okay, and the graph of a quadratic function has a name, and the name of this is what's called a parabola. Alright, so the name of this curve is known as a parabola. Now you notice there's some symmetry going on here. It has the vertical axis of this parabola happens to be the y-axis, and so it's symmetric about the y-axis. In other words, this side of the curve here is a mirror image of what's going on in quadrant 2. So quadrant 1 is a mirror image of quadrant 2, and quadrant 2 is a mirror image of quadrant 1. Now, this part down here, this point right here at the origin, this is known as the vertex. The vertex. So if we're given this, we want to be able to tell where's the vertex located. Well, in this particular case, and I'm just going to label this with a V, okay, the vertex is 0, 0. Alright, the vertex is 0, 0. Now let's take a look at if we start moving this thing around, what does this thing start looking like? When we start moving this guy around in the plane, move the vertex over here, for example, and now we have a parabola over here. How does that actually change this? And so that's what we want to kind of look at. We're going to look at that, and then we're going to also look at what happens. How can I flip this curve? Get a reflection about the x-axis. Alright, so we're going to kind of look at some things like that, and I think what I'll do here is just redraw it, or at least attempt to. Okay, so this guy here we're going to say is y is equal to x squared. If I wanted to flip this guy so we get a mirror image about the x-axis, we just throw a negative out in front. Throw a negative out in the front, and that'll cause this to flip. You see that? That's pretty interesting. What if I wanted to get the curve to move up vertically? Let's say up to 2 here on the y-axis. Well, we would just add 2 to it. You see that? What if I added 2 to this one? Well, that would cause this curve, and I'm going to draw this in purple. That would cause this curve to go up 2 units in that direction, so it would be